All right, so next is a very important concept of standard scores. And you will see the application of this score thoroughly throughout the statistical analysis that you're going to perform in future. And a lot of the statistical procedures that are used in biostatistics, they also have standard scores in them. And what are standard scores? They are just scores converted into standard deviations. So basically, a standard score or Z score. So because standard scores are based upon Z distribution, they are also called Z scores. Represents the number of standard deviations that a data value X falls from the mean. So this is how we calculate Z score. Z is equal to X minus mu divided by sigma. So here X is a particular value, and we deduct that value from the mean of the values. And if you remember, we used to call this particular product deviation. So first we calculate the deviation of a value from the mean, and then we divide that with standard deviation of the data set. Okay, so if we have like a population set and we convert each value into standard score, so we will use each individual value and we will deduct that from population mean and divide that with population standard deviation. But if we have a sample and we want to convert each point into the standard score, we will deduct each sample value from the sample mean and we are going to divide that with the sample standard deviation. This is how we convert values into Z scores. So here's an example. Let's see this example. Let me make things clear for you. Right, so the test score for all statistics finals at Union College have a mean of 75 and a standard deviation of 7. Okay, so we have a mean and a standard deviation. Find the Z score for these values. For example, how we can convert 85 into Z score? Z is equal to 85, which is the value, minus the mean, which is 78, and we're gonna divide it by the standard deviation, and we will get the Z score. So this is the procedure. We're gonna apply this to all the values. Let's see what are the results. So first, when we deduct 85 from 78 and we divide on 7, so we get 1.0. Now, what is this 1.0? This means that 85 is exactly how much away from the mean? Mean is 78. It is exactly one standard deviation away from the mean. And you can confirm that. How can you confirm that? So we have the standard deviation of 7 points. So if you add 7 to your mean value, okay, so that shows you around 85, which is near to 1.1. So 1.1 and 1.0, that is basically the average here, or your other way you can deduct it from 85. So you would get around 78, right? Okay, so next is when you have your value as 70, and now remember this is a lower value than 78. So this value is less than mean, so it should have a negative Z score, because when you deduct this from the mean, there will be a negative deviation, and when you divide that with the standard deviation, you will have a negative number. So this is negative 1.14 standard deviations away from the mean. That means it falls on the lower side of the mean. And finally, if we have 78 value, which exactly falls at where the mean falls, so it will have 0 standard deviation away from mean because it falls at the mean. Okay, so by using the relative scores, we can actually understand that how people are performing. Here we have an example where John received a 75 on a test whose class mean was 73.2 with a standard deviation of 4.5, and Samantha, which is a student of another class, she received 68.6 on her test, and the mean for her class was 65, whereas the standard deviation was 3.9. So these two people, they belong to different data sets. They have different standard deviations, they have different means. But if you want to know how much good one particular person performed as in relation to the other person. So you can use z-scores. So if we calculate the z-score for John, that is positive 0.4, whereas for Samantha it is positive 0.92. So since we are talking about test scores, the more the better. So you can see that the higher number would be better score in this situation. So 0.92, which is Samantha's scores, is a lot better than John's. All right, this is how we use z-scores.